Let me know when we're on.
Just fire up the browser and try
Yeah, the disk version is doing. The disk version has one phrase that's not in the game.
Oh, and come on up here. We saved your seat, Owen. Okay, you like that seat better? Are we online yet?
Yep,
We're on, okay. Welcome back to part 2 of the 2019 Chicago TI International Fair. This is our 37th year, and we have a good crowd today. We took a little bit longer luncheon break than well, I won't say than I expected, because I actually, we're probably 5 minutes sooner than I actually expected. TIers, as you probably know, is like herding cats. You tell them a certain time and, well, time is immaterial. But that's okay, because we have plenty more to go today, and our first presenter this afternoon will be Eric Firestone from CAD Electronics. And I'm going to just take a second to mic him up, and then away we go. There you go. I'm going to turn the light down so that they can.
Okay. So last year I introduced Rev 1 of our CAD 995C TI-99 replacement. Used the 6x6 board. The board cost on that was extremely expensive, so I re-revved the board into Rev 2, so I've got it down to 3.5 by 5 or 4, and or 3.5 by 4.5. And this board, I can actually manufacture this whole board for $479.95, where before it was $799.95 was the actual cost that CAD had on the board. Obviously, it's not cost effective to do that. So this rev of the board basically does everything the first rev of the board does, except it doesn't have the peripheral expansion box connectors and the cartridge connector on it. This board originally was designed so that it would fit in a real TI console and could be used, and it would be transparent to the user that this was a TI 99.4A or if it was an emulated board. So, so here we are. This is just a picture of the emulator on a VGA monitor, and so there's Rev 2 of the board. This particular board I completely hand populated, and at my age a microscope was absolutely necessary. But I did get through it, and after looking at the solder joints, I think mine are probably just as good as what a reflow soldering machine would do. So the neat thing about the reflow soldering machine is that it will ramp up the temperature. Basically, you put solder paste on a board, and you do that through a stencil, and then the solder paste is kind of tacky, so it will hold the components in place, and then you use hot air from the bottom and the top of the board to preheat the board to a certain temperature, soak it a little bit, then ramp it up to a critical temperature to where the solder flows, and then the temperature ramps back down rapidly as to not damage the components. So in this case, if you're hand soldering the board, the chips are rather large and the silicon is actually quite small in the center of the part. So the heat that you're putting on the pins is, I mean, you still have to follow good practices and not keep the heat on the pin for a long period of time, but you can actually get by with hand soldering this board. And now the new intent on this board is to offer it several different ways. One is fully populated and tested, And the other way would be to offer it as a bare board, and you would be provided with a manual to an assembly manual, and all the binary images that go on 4 microcontrollers on the board. And you would have to buy a $12 programming dongle to put the code on the board. But the latest code would always be available on the CAB website for download, and would just make it a lot easier for upgrades and things like that. So the actual resolution is 640 by 480, and everything from the TI is scaled to that resolution. So it'll always be full screen no matter what mode you're in. And you'll always have the border around the outside, just like a TI would. Revision 1 of the board. Then this is the finished product, and it will be offered with a case or without a case. With the case, it's like $30 more, and the case would be completely machined and have the buttons, the speaker, and everything inside it. That's what's inside the case. And that's actually a pretty high quality speaker that I put in it. Super AMS is included with this, 1 megabyte of it. It passes all the tests for the from this program that was written by Bob Camry and Bruce Harrison. Just some other software that runs on the emulator. And actually there's only a few programs that I found that won't run on the emulator, and the reason for that is because the V9938 is slightly different than the 9918. Running 80 column mode with funnel web. This is a program that I wrote for testing the SID card, and this is all done in C, and it was done using well, C and inline assembly, but the code was all compiled with Clint Pulley's C compiler. And in this case, the C compiler was rewritten by, I forget the name of the person that rewrote it, but it was offered as open source. So I ported it to Pella C and recompiled it, and so now you can do cross development for this particular platform. But this is running graphics mode 4 of the V9938. And the Windows-like controls, the sliders actually do operate with the mouse, and the mouse is provided by the V9938 as well. Another test program. This one just allows you to test the joysticks, the sound and the speech, and the mouse. And you can also test the keyboard.
Can you show them the joystick that you developed for? I mean, what would you recommend the joystick? I think people will appreciate that. You have your joystick there where people can see it. So people really appreciate what you're using for a joystick.
Oh, okay, yeah. So the joystick is a true USB interface. And right now I only have one driver provided, so you basically have to use this style joystick. And but it works quite well. This is another Graphics 7 test program that I wrote, and I took the same graphics library that I used in Graphics Mode 4 and used it in Graphics Mode 7. Had to change a few things. But essentially this is testing all the hardware acceleration of the of the V9938 to see how fast it would actually update the screen and move things around. And it worked quite well. Just a couple more programs that run on the emulator. So the features, expandability, there's a new interface on the board. So originally I had the interface so that it had the peripheral expansion box connector on the side and the cartridge connector on the top. And this board the intent was to be able to put it in a true TI-99 4A console and as a replacement board. But like I said, the cost is quite prohibitive. This board here does essentially the same thing, but it has a different interface on it. The neat thing is that the interface is a serial peripheral interface, and it'll go to another board that'll have these connectors on it. So in that case, the only thing the question that needs to be answered is it fast enough? And there are some games that I can play to make it fast enough. So, but anyway, the peripheral expansion box and the cartridge would be plugged into this. So some of the benefits of that are if you want to do a ROM dump of a cartridge, you basically can use the tools like you would on a TI, except it dumps it to a virtual disk. That virtual disk is on an SD card that's in a FAT32 file format. So you can take that FAT32 file and use tools on a Windows PC to convert that into any format you want for any emulator, or if you just wanted to have it for the CAD emulator, it's already in the correct format for it. The other thing with this interface, so the first board that I intend to make that will be an expansion board for this will have a serial port and a parallel port on it with all the handshake lines. Additionally, it will have several connectors that you can plug cartridges into that will be 3.3 volts. A board that will be done after that will actually plug in where the peripheral expansion box fire hose cable interface went. So that board will be able to be plugged in here as well, and you'll be able to use real TI peripherals with the board or with the expansion box. So portability, the weight of this, instead of having to carry an expansion box and the TI console, of course, the speech synthesizer, all that's already on the circuit board. So that's something that, I mean, you can pick this up with one hand and walk away with it. So that'll be an advantage if you wanted to take it for demos and things like that. V9938 with VGA output. The SID MOS 6581 is implemented on here, and I will probably revisit that because I've heard that some things don't sound like they're supposed to on it, but we'll get that squared away. But like I said, the code will always be available on the CAD website for download. Well, not the code, but the binary images that run on the processors. There is a 20 megabyte solid state hard drive included on the board. It is a virtual hard drive, and it uses a file that's 20 megabyte. It can be edited by several editors that are freeware. I can't remember the name of the one that I found that worked with it, but I'll post that, and it'll probably have a link to it in the on the CAD website. 1 megabyte of Super AMS memory, and so there's actually a main menu on this. So if I reset it, what's happening here is that it so the V9938 is kind of fixed, and you can't really change its functionality. So what I did is halted the 9900 processor and kind of hijacked the video controller, and so I could put my own menus on here. So what Disk 1 allows you to do is select, and you can put like I think up to a 64 gigabyte SD card in here. So you could have thousands of disks for the TI on this SD card. Additionally, cartridges can be placed on the SD card, and you can have unlimited number of cartridges. And CAD provides all of the TI cartridges. And some of the hard to find and other cartridges are slowly becoming available. They can be put on here as well. So currently there's 4 floppy disks implemented and the hard disk, and that's standard on the emulator.
Can I ask a question?
Uh-huh.
So this 20 megabyte solid state hard disk drive is meant for holding disk images and cartridge images, or is this meant for that the TI as such can access it like a device?
Yes, it's meant for so it's based on the Therinos Pico IDE drive, and it's using the Fred Cal DSR.
Okay.
But so far I've been using it probably well over a year now and haven't had any issues with it at all. I think the software that he did is phenomenal, and it's stable. So all the interfaces are USB. So you have a USB keyboard, mouse, and joystick that plug into it. They're micro USB connectors. And what I basically did is use a micro USB to a standard USB connector for the individual devices. There have been some requests to put standard USB connectors on the board, but that increases the real estate just a little bit. So, and the board is pretty tightly packed as it is, so I probably won't do that.
Is the mouse easily accessible programmatically?
Programmatically from the TI code, yes. So anything that,
Your assembler or something?
yeah, if you, well, you would have to rewrite, and that's something else that I've thought about doing, is using graphics mode 4, putting together a package similar to FunnelWeb, but with a more modern editor. And in later versions of the emulator, I'm thinking about making it multiple speed, so that you can go extremely high speed, so you can do nice scroll bars and things like that, and make it a Windows-like interface. And then programmatically, you would be able to write to a register, and it would automatically change your speed. And you could also do an RTOS, to where the RTOS would be smart enough to, well, you would probably have to have a dialog come up, and you'd have to enter parameters on what speed you want to run the program at and things like that. And then like with the games and things that are already written for the TI, without writing a very elaborate RTOS, real-time operating system. It wouldn't really be a real-time operating system, it would just be an operating system. But with an operating system, you could give control of the processor over to another task, like say a game that you're playing or whatever, and then when it's through, it'll come back to the RTOS. And that could be done a couple of different ways. One is that you could make it reboot the machine, because the graphics mode may be different, but then the neat thing about the TI is how fast it comes up. You know, every time you turn on a Windows computer, you're waiting 10 minutes for the updates and everything else. A TI computer, you could do an RTOS on it. If you had a high-speed processor, you could, it would come up instantly and you're ready to go. So there's a lot of capability that this system has. And as time goes on, another thing that's proposed for it right now is 16-bit true color mode. So it would be 640 by 480 in 16-bit color, so you could do some really nice graphics with it.
Regarding part of his question about the mouse. Now the mouse interfaces to the 9938,
Yes.
just like all the other devices. So
Yeah, if you read the data sheet for the 9938, it talks about a mouse interface on it, and that's implemented identically the same way that is.
yeah, so it's not. So if you already have a 9938,
Yeah, and
set up,
you've written code for it. That code should run on here. Well, it won't run on here directly, but you could take the pieces of that code that do talk to the mouse, and you could compile it into a new program that runs on this. In other words, if your program's going to be reading specific registers, and the way they've implemented the mouse is the status register, there's like 9 status registers, and then there's a status register pointer that you would select the one that is specific to the mouse, and you would get the coordinates that way. And actually, this is STM code talking to the display right now with the mouse. And so the same code that I wrote here, the registers that I'm writing to, I could flip over into a TI program and do the same thing. So the pros and cons. So very reliable solid-state electronics, accurate machine behavior, at least that's the goal, is to have it work identically to the way the TI did. All graphics modes of the 9918 plus 80 column text and 3 extended graphics mode with hardware acceleration. Hardware acceleration is kind of neat because you can basically write a few values to registers and you end up with line drawing and things like that that's super high speed. And there I say this is kind of a con, but it's compatibility with nearly all TI software. And the reason for that is because the 9938 implements a few things slightly different. One thing that happens on the 9918 is the video memory wraps at 16.384. So some programmers, when they were writing things, I think MASH is one of them, they actually rely on it wrapping to work correctly. So that's why in the CAD emulator there's a little checkbox that you can say wrap at the 16.384. And that's so that MASH will run on the 9938. And some other things. So the previous board is probably going to get a new spin, and it will still be offered, and I'm going to try to bring the costs down on that. So there are some new parts that I'm looking at that are running faster, and if I could eliminate a couple of processors off of this, get the size of the board reduced a little bit, I could probably still offer this board that would fit in a TI-99 console as a replacement board. This board as well, as I look at these new processors, I can probably even further cost reduce this board. So right now I'm doing a 1-week burn-in on the board. Well, I will be doing a 1-week burn-in on the board before shipping it, and the availability will be, right now it's probably going to be 4 to 6 weeks because they're going to be manufactured on a onesie-twosie basis. So the price compare. So the 9938, you can't really get a card or a board right now without finding old stuff, maybe on eBay. Periodically it pops up, but this is standard on there. The 20 megabyte hard drive, I don't know if you can get a SCSI interface now, but that one pretty much is not available. The 1 megabyte SAMs, I've seen it $80. These are pre-populated boards. Serial port, $100. Console, $50 to $100. Speed synthesizer, upward of 50. I've seen it lower than that in a couple of cases. The SID, I don't know if it's a, I guess Jim is going to be redoing a SID board.
Correct.
Okay. And so right now availability is 4 to 6 weeks. So emulation versus hardware. A lot of people like the real silicon. The problem is that the real silicon is getting old and it's more failure prone as time goes on. Additionally, capacitors degrade over time, and on the power supplies, a lot of the real old consoles, just to prevent failures, you might want to think about replacing the capacitors. So in emulation, obviously the emulation is trying to use new silicon to do the things that old silicon did. So even in an FPGA, it's still emulation. So anything that's built today that uses an FPGA or a microcontroller is still emulation. The benefits, one is use modern hardware for better reliability. Accuracy, fix any hardware bugs. User experience, if done correctly, no differences from original hardware. And my intent is to make this so that if you sat a real TI next to this, 2 people working on both machines, you can't tell the difference, except for the fact that you have way more hardware with the emulated version. Well, way more virtual hardware, let's put it that way. So
Can you run a P code on it?
right now I don't have the P code in it, but that shouldn't be a problem because it's already emulated in the CAD emulator. So what I would basically do is, and actually this is completely based on the same code. When I was writing the PC emulator, I was thinking, what were the things I needed to do to make this work on hardware and graphics? So I took all that code and rewrote it. Well, not rewrote most of it. Most of it just worked directly. I had to do a lot of reworking of the core to make it work on an STM32. And the other functionality, like the Horizon RAM disk, those things, I should just be able to take that same code base, put it into the project for the STM part, and it should just work. There's usually a few things you have to fix along the way when you do that, but for the most part that should happen. So yeah, I could do P code on that. But right now it doesn't currently have it. So microcontrollers start out with a specification of all of the hardware commands. So the move commands, the add, multiply, jump, branch link workspace pointer, those all started out on a specification. And somebody put all that specification into silicon in the old days. Modern microcontrollers, some of the functionality is actually performed in software for the opcodes. So in a sense, a microcontroller is an emulator. It's emulating a specification. So as I explained earlier, the new peripherals using the same CRU methods as the TI will be available on another board. But that brings the possibility of doing A to D converters. You could do MP3 players, video capture, vocoders, all kinds of different hardware could be easily created to be plugged into this. And you would be writing your code in TMS 9900 assembly language or C code or whatever you choose to, and be able to talk to these things externally in real hardware. And in my opinion, from a scholastic point of view, working with old hardware exposes people to more of what really has to be done in a microcontroller world to make things work. When you're dealing with modern languages like Java and other things like that, a lot of times people are using things that are already written, and you just use this library and you've got an Ethernet, you've got a web server. Very easy to do, but if you really want to learn microcontrollers and computer science, this is the right way to do it. So I've got 3 new programs that I'm going to be offering that facilitate making programs that work with AMS memory. And so one of them is called map file. What it does is it parses a list file that's created from the Albeard assembler, and takes all of the function names and variable names and gives an address. And then I have another program that takes that. You create a C header with all of the function names as integers, as they would be in the map file. And the address update program goes off and it grabs the map file, takes all the addresses and plugs in the absolute addresses for those in your header file. And then make AMS allows you to specify a page that you want a particular P99 program to live in. And doing that, you essentially can create a super AMS program. Of course, you have to provide trampoline functions and other things so that you can jump from page to page, but it would allow you to actually get to the memory that's available out there, because without it you really can't. Well, other than doing assembly language in your jump programs and then trying to figure out where the addresses are. I mean, you could manually look through a map file and find out where the functions live and things like that, but this makes it so much easier. And that package will be available probably within the next couple of months. And additionally, we're going to try to do an IDE for that with a wizard that allows you to say, I want to use a graphics mode for the video card. I want to use these pages in AMS memory. And it will automatically create a skeleton program with all the trampoline functions and all of that in it. And of course, the trampoline functions that I wrote might not be optimized the way somebody else might like, but you could tailor those to your liking. So how is the 99.4a different from the 99.5c? So the VDP on the 9900 was a 9918, replaced with a V9938. Sound, the 9919, which wasn't really a 9919, it was an SN something, replaced with the 9919 and the SID. Speech, not included on a TI-99, included on the emulator. Video was originally an RF modulator, now it's VGA. Well, it was actually NTSC that you could plug into an RF modulator. Memory, 16K versus 1 megabyte of super AMS memory, plus 128K of video memory. Hard disk, none, 20 megabyte on the emulator. And RS-232, you needed a peripheral expansion box, and it's included on the emulator. And then the version included on the emulator, it does not have the handshake lines, just has RX and TX. So right now our prices are $479.95 plus shipping and handling for a fully assembled and tested board, 4 to 6 weeks delivery, $30 for a case, and a bare board plus a BOM, 4 CPU image files, and instructions, $79.95 plus shipping and handling. If you want to get real ambitious and solder parts yourself. And then the AMS development tools for Windows 10, $39.95. Those aren't available quite yet. I think that's the end of my presentation. So anybody have any questions?
Eric, can you repeat the question so that the people at home can hear them as well? Because it's very difficult to hear anything.
Yeah,
that
I'll do
anyone says
that.
in the audience.
Okay. Yes.
So how much was speed accuracy a topic for you? And also the topic of if you're running a microcontroller, it can only do one thing at one time. But if you're running the same thing on hardware level, many chips can do many things at the same time. So how did you solve those topics, like speed accuracy and having
Okay.
to do many things at once?
So essentially the question is, how did I handle speed and accuracy of the emulation, and additionally, how did I handle all the multitasking that goes on between different pieces of hardware? So the way I handled it was the video controller, essentially the V9938 emulation is done on an STM32F7 part, 746 to be exact. And it, from a speed standpoint, that one I'm basically allowing to run as fast as it can. So the hardware interface to that chip is actually a parallel interface. And it looks very much like the same video or the hardware interface of a V9938. So you've got a data bus, you have a read-write line, and then you have a chip select, and additionally an interrupt output. So those exist, they're virtual, they're done with I/O pins on the microcontroller. So when you want to actually talk from the 9900 core to the VDP display, what's actually happening is that you're so off of the interrupt, off of the VDP, the interface over here sees that interrupt, and the interrupt service routine will basically halt the processor, allow the VDP to do what it's doing, and then in between the interrupts, you can actually send stuff to the VDP. So you would do that essentially like you would on a real TI-99. So in the emulator itself, to handle timing, I'm kind of answering both questions with one answer. So the timing in the 9900 is provided by a hardware clock. And that hardware clock's frequency can be changed through the INI file. So the INI file actually lives on the SD card, and the INI file is very similar to the INI file that is used in the CAD emulator for the PC. So what I tried to do is we know that the video interrupt wants to run at 16 milliseconds. So another hardware timer inside the machine, or inside the core of the VDP, is running at 16 milliseconds to make that happen. The actual time that it takes me to refresh the entire screen is only a very small portion of that 16. And handles that interrupt. So, but from that perspective, that was handled identically the same way the TI-99/4A did. But these both timers for the VDP and the core can be tailored to get the time as close as possible to the real machine. And we know the processor ran at 3 megahertz, and that timer is running identically well, I wouldn't say identically the same, because you've got a lot of things that have to happen in that particular time chunk. But even in this case, I chose the processor such that I'm not using that whole time chunk to do what needs to be done for that particular instruction. So I don't know if that answers your question, but
Bob Carmody asks if there's a chance of including the 192K VDP RAM as per the 9938.
yeah, I've got plenty of memory on the chip. And actually, I may have already done that, but I can't remember if I did or not. I know that there's some things about that RAM. One is that RAM actually, I can't remember exactly, but I'm thinking that RAM isn't used by the VDP. It's RAM that can be used from the user program, that additional RAM. But I'm not 100% sure on that.
Ask Bob if that, he's watching, ask him if that answers his question.
Okay. Does that answer your question?
We'll know in a moment. In the meanwhile, go ahead and answer the other question. I see some hands back there.
Yes.
I had one of the original TIMs, TI image makers when they first came out, and that used the 9938. And one advantage was in funnel web, if you went to 80 column, you could also have split screen, a horizontal split screen, where the top half of the screen could roll a text file, and then you could switch to the bottom half and you could roll another text file, so you could compare two text files against each other. Plus it had the 256 color resolution. They had YAP, which stood for yet another paint program.
Mm-hmm.
And that was, for the TI, it was a high resolution paint program. It was pretty nice. One thing with the TIM is they stated explicitly it was not compatible with the stock TI.
Yes.
ROMs 0 and 1 had to be removed and replaced with a little tiny, what they call the daughter board, called the SOB for son of a board.
Mm-hmm.
That would plug in where ROMs 0 and 1 would go to correct whatever these incompatibilities were. They also had a little space left. They put in their own menuing system there. So when you started up your TI, it came up with that menuing system. It scanned for any hard drives, floppy drives, cartridges, stuff like that. You could select what you want to run. So I don't know what incompatibilities there were that it corrected. I know there's, what was it, the Digit, AVPC. I think they sold those in Europe mostly. They fit in the P box for 80 column compatibility.
Okay.
Yeah, so that's what I remember about the TIM with the video. So it was sort of nice having the extra video memory, because there were some things you could do with that.
Right, right. So the question is, the hardware compatibility between the V9938 and the TI console, and the fact that the TIM card I'm thinking the TIM card used a V9958. Is that correct?
I think it was a 38. It was a rather big daughter board that replaced the regular video chip, and it was cantilevered off to the side. They should have provided some means of support for that. 'Cause
Okay.
after a while, it flopped around in the socket and got loose in the video socket.
I see.
The only difference between the 38 and the 58 is the 58 dropped mouse support and light pen support and offered RGB out and no composite. So if your board had the original video connector out, it was a 38.
Okay, it's in storage. I'd have to look at it.
Yeah, I
see
mean, if you
it
use your TI monitor with it.
Well, they both have the same incompatibility with the ROMs.
Yeah,
If
yeah.
the TI ROMs write invalid registers and rely on the 9918
Yeah.
masking for
Yeah.
it to work, that's all that's
The
wrong.
monitor I had was that Magnavox monitor that was sold in computer magazines for Commodores. and it was the only 9-pin monitor that it actually worked with. And I tried PC monitors, regular 9-pin monitors, and I would come up with stacked images and stuff like that. And for some reason, that Magnavox was the only one that had a mode selected to work with the 10.
Guys, remember that no one at home can hear your questions, so please don't talk about yourselves.
Yeah, it's got 5 buttons on it.
Okay, so
Console, because I got fed up with having the dogs moving around and stuff like that. I was going to hard set up the thing in, but that's a project for another day.
okay, so we're talking about incompatibility and the necessity to create an extra ROM to handle the incompatibilities of the V9938. Is that pretty much your question?
Yeah, where the tin maker had the SOB with the 2 replacement grabs.
Okay. So in my case, I had the freedom of rearranging a few things on the V9938 so it doesn't use an extra ROM.
Okay.
Yeah. Yeah. So some of the functionality of the 9918, I basically started with that model and then worked it into the V9938.
Bob Carmody points out online that the difference between the 9938 and 9958 is that, I think, if I get this right,
958 doesn't support a
58 doesn't support a mouse.
Oh, okay.
So,
Yeah. And I do.
by the way, he said you did answer his question.
Oh, okay. Good. All right. Any other questions? Yes.
What about debug possibilities for the registers of the CPU, or to see what is in the VDB RAM or?
Oh, debugging.
Yeah.
Yeah. So, since I have a serial interface on this is one possibility to integrate the CAD emulator with this, so the CAD debugger could be used with this. Right now I don't have that implemented, but that is a possibility. Additionally, you could almost have it so, do you remember the mini screen from the DOS version of the CAD emulator? You could do something like that on here.
But it's not implemented yet.
It's not implemented, no. But actually, the way I do my development, I do it all on the PC, run it on my emulator, and since the emulator is virtually the same code as this, it runs. And I have no problems with anything so far. Any other questions?
You implement a feature, like you go back to the menu screen so that you, one of your buttons is turn debug on, so that you set your breakpoints or whatever. Maybe you can, maybe you can't do that, so that by simply pressing maybe like the F12 key or maybe another key on the keyboard, you could actually pop up the debug screen on a 99.5C.
Oh, okay.
You sort of follow what I'm saying? Like you could actually, at any point in time, you could hit a key and flash back to a separate, outside the 9900 environment, but you can read all your registers.
Right. So the question is can a debug screen be popped up on the 95C? So the answer is yes, and it could be attached to a hotkey. So you would hit the hotkey, but I kind of like the mini memory approach a little better, where you'd have part of the screen, or you could actually change the size of the TI window to something small, and then have the rest of your debug interface on the screen. So yes.
Yeah, that sounds better there.
Okay.
What you're describing.
Yeah. Any other questions? Okay.
Thank you very much, Eric.
You're welcome.
Now, I know it took you 6 weeks to develop this, wasn't it?
Yeah, something like that. Yeah.
Okay. Okay, well, we're going to take a 5-minute break while our next presenter, Lee Stewart, sets up his equipment and Eric breaks his down. Now, in the meanwhile, since this presentation began, Phyllis Pesca has brought in a lot of stuff that she's giving away. Some boxes, some floppy drives, some 3.5-inch floppy drives. If you use those are there for the taking. By all means, help yourself. Otherwise, they become door prizes, and I don't want to have to carry them over to Panera. So we'll take a couple-minute break, and if anyone has any announcements they'd like to make about any meetings or anything like that that they're going to, or just anything at all they'd like to talk about, we have a couple minutes to do just that. Otherwise, I'm going to sit back and remind everybody that you have to have your cars out of the garage.
You know what's funny is, when I started getting, and so I number of people charges and as I'm pulling these out, I'm like, I'll save somebody.
Okay, we have a very nice young lady coming in to take pictures for us.
Haven't seen the nerve somewhere.
Oh, yeah, you guys are running the prices up.
Yeah, how we're doing a circle thing. So he's probably more of
Right now, we've got
Take your shirts off.
getting more people. Right now, we've expanded to the lobby and the lounge area. I worked with local club meeting last Saturday. The room will hold that so that's sitting in the lobby. The lobby computers. That room is,
You're shorter than Jim.
Klaus.
I have a feeling that this would even have
You're in great shape. Oh, you found this a shape. Yeah, I know you're in this too.
okay, yeah, everywhere else.
Not everyone. You Alright, you're okay. Since we're doing good.
The next day, I'm kicking myself. I didn't know it was coming on. Somebody's got to write the picture first, right? Ever.
Eric, where's your wife?
Yeah, the folks who got it last Saturday want to do something. It was held in Dallas for 3 years, but there's BCFs. Right here.
Pennywise and Stephen King's It.
I was one of them.
I think I'll just ever stand on a chair.
Free cartridge. I couldn't sit through the original. He's got a couple of them wrong. You need to sit in the we have a spare console. It's Halloween.
Oh, is that the reason? There you go.
Is there anything that says TI besides my hat?
They're afraid of the concept of clouds.
I don't know what I do, but I did some
It's going to
I even started yet.
I said a long time ago, the British TV series Dr. Who. There's a good chance it was. Disguise themselves as police patrol. Artificial.
one of the tabs there.
So listen, Eric, can
Go out through there.
Okay, all right, our seat's up.
My letter.
You have yours.
Last page because there's a lot of. Drive it online.
Now, guys, the way it's gonna work is this. Every year, Barry asks us pictures, and every year, Barry says, who's this, who's that, who's the other one? If you can't see the camera, they can't see you, okay? So, that means that you can't hide behind anybody else. Now, I gotta go get that photographer. Don't move. Before I do this, do we actually have a camera? Does anybody have a camera?
I do in my lab.
Okay. I got a high quality. So we have a camera. Because
Cell phones do nothing else.
cell phones have to do. But I don't want to get everything to find out. I think it's
Yeah, the only one we use is
How far back?
Yeah, it seems to that simple.
It's actually, I can actually verify that.
There was an excitement.
You're still streaming? Yeah.
No, this was a test to verify that I could get
Okay, here's the check. Yeah. Everybody.
No, I had to come all the way back.
This is our photographer. Would you please get in there so she can go back to work? She doesn't do this for a living. Yeah, get in.
There. But you can leave her with the camera.
There, they got the camera that they want.
Okay. I noticed that I had to go all the way back to like that fourth row of chairs before. That's the button that fires.
We got about 6 cameras.
My wife would like a picture. Let me get you. Dude.
How about this? How about if we have you stand on the chair?
Everybody on purpose, dude.
Inhale. All the different cameras. Now we get in.
Any other demands?
Like I said, I don't think, that was why I said that fourth row of chairs before it gets everybody.
Thank you, guys.
Be careful with that.
I think it's a hat, you know.
Ready?
All right.
Just show,
One more, okay.
Out of film.
She forgot to pay.
Now I got a couple more. Everybody just.
Go get the camera.
On the chair.
Thank you very much. Now, if you'd like your camera back, that'll be $10.
This is our Halloween. Yeah, I'm glad.
At least sign in. At least sign in.
It's not future meeting.
I knew you were.
Yeah, that's true.
I was fully expecting a correction here, like comments here last night. You know, I made some comments about that.
Okay, everybody, if you'll all back, Lee is about to do.
Oh, yeah?
Yeah.
Do it in June or something.
It's over.
But, or somebody just do one and then I can.
Alright, you just gonna sit then?
Probably, yeah.
Not that size.
Alright, is your source working?
I guess.
I'm still trying to figure out what the mystery was.
Okay, I'm gonna get everybody going here. Boys and girls, up to the front.
Okay.
Time for show and tell afterwards, and everybody can pick up their disc, candy bar, or bottle of water. Anything I don't have to carry out of here would be.
It's an A-B switch.
Okay.
Okay, is everybody ready?
Yeah.
We have been.
Are we still on?
Yeah, we've been on.
We haven't been on?
Yeah, we've been the whole time.
We have been on the whole time. Oh, well then. Everybody at home has seen the wonderful organization that we have in terms of,
The TI experience.
yeah, it's a TI experience. So far, all the demos have worked perfectly, which means that Lee is in trouble. A real TI demo, as anyone who's ever done one of these things that knows, doesn't work the first time. It works eventually, but not the first time. So, come on up. Everybody come on up if you're going to come up. We still have a seat or two here available. This is a packed room. All those people at home probably can't tell. But we're elbow to elbow here. I see people actually touching elbows. Go ahead, somebody touch an elbow. Don't make a liar out of me. We have a pretty good turnout today. Some people have just gotten here, in fact. But that's pretty much typical too. We're waiting for Tom Clayton. He won't be here until 5 minutes before the show ends. He never is. At any rate, we have another presenter, and that would be Lee Stewart, who is going to talk to us all about, well, Lee's going to tell you what he's going to talk to us about.
All right, yeah.
I mic you up.
All right.
Can I just put it on your beard? No.
That probably won't stay very
Probably
long.
won't work. Oh, okay. All right, there you go.
Okay. What's that?
I will.
Well, it will muffle it, you think?
I'll
Well,
turn the lights down as soon as you're ready to start showing.
sure.
Right now?
Well, yeah, it'll be soon, but you can, I'll let you know. This mostly has to do with bitmap graphics and plotting functions. Some of you know that follow the TI group on Atari Age know about a programmer challenge. The thread is titled "A Worst Programmer's Questions," and one of the questions fairly recently had to do with plotting the sine function on Cartesian coordinates. So everybody gets out their skills and plots in BASIC, and trying to think if anybody else used, I guess BASIC, extended BASIC, and FB fourth, and were the only ones. I don't know if I don't remember if Brian Fox did it on with his Camel 99 fourth. He may have. I don't have that right at my fingertips right now, but I had said that it's a piece of cake in FB fourth because the graphic primitives are already written and bitmap graphics is easily available. It's not so much in BASIC. You can't do it with regular BASIC because there's not enough room for one thing, and the language doesn't make it easy. You can do things like with Harry Wilhelm's compiler, and probably with the My Little compiler that can't come. What's that?
Yeah, the My Little compiler is the one from Guillaume Tello.
Right. Yeah, Guillaume Tello. You can get access to the bitmap mode, but you still have it. That then gets compiled, or rather assembled, using assembler. So I did it pretty quickly, but it didn't work. And I was scratching my head. I discovered a couple of bugs in FB4 build 11, which is why all the cartridges here today are build 12. It turned out that my floating point library, which is a port of the L10 library from the Geneve 9640, it needs a couple of extra buffers that I wanted to keep in scratchpad memory, because that's on the 16-bit bus. It's much faster than putting it in the 8-bit RAM of the 32K expansion. So I was grabbing areas that I didn't think were being used in the scratchpad RAM. And one of them I decided to use for one of the floating point numbers was in the GPL workspace, because we're not using that in the floating point library. Well, when I decided to incorporate speech and sound processing in the fourth ISR, the interrupt service routine, it's using GPL workspace. So every time I ran the sine function or the cosine function or the tangent function, it got stepped on by the interrupt every 60th of a second. So I found another spot. I used part of the fourth workspace, and hopefully that's safe, although nothing's guaranteed. Anyway, I got that working, and then I decided that I was going to change the plot to add color to it, because one of the things you can do with bitmap graphics that you can't do with other modes is you have a finer level of color. It's still not fine enough. It's not per pixel, because there's not enough memory in the TI. But there is every 8 bits. The color is at 8-bit granularity. So if you change the color of a dot in bitmap graphics, then any other dots that happen to be on in that 8 bits change color as well. So that can be a little upsetting, and you have to then you wind up having to plan for that, which is not as bad as in graphics mode, where you have color every 8 characters, which is 8 times 8, 64 dots. Is that right? That can't be right. 8 across. 8 times 8 is 64 dots across times 8. So that's the total number of dots that are going to be the same color for any characters in that character set. Every 8 characters. So that's that's difficult to work with. Anybody who's done a lot of design for games in BASIC using the character set know what I'm talking about. Okay. Let's see. So FP4 2.0:12. I'll post that sometime later this week or next. And a new F blocks, which is only cosmetic changes. I didn't really put any new programming into the F blocks, but it won't load. There are like 3 or 4 binary loaded utilities that you can choose that won't work with anything but build 12. That was the cosmetic change. I made the test work for 12. All right. Okay, let's see what we have here. In bitmap graphics, it is a very similar setup to graphics mode, except that in graphics mode, you have a maximum of 256 characters to deal with a screen that is 3 times that. 768 characters. So that if you're using that to plot dots by setting up the character pattern to your to do your bidding, if you get up to the, well, in BASIC, it's, how many characters is it, Tercy, that you have accessible in BASIC?
I think it's 96.
96 characters? Yeah, it's not 256. So you will wind up using all of those characters. If you need a 97th unique character set up to plot the dots you need in your graphic, you're out of luck. Where was I going with that? The TI logo cartridge. You remember, those of you that have used it, do you remember, or your kids have used it and they started slamming things and you wondered what was going on? They said it ran out of ink. Well, it's because it was using graphics mode and it ran out of unique characters to do anything, and it had to stop. Anyway, you don't have that problem with bitmap graphics. Here's an example, the screen image table for the letters A, B, and C. I have this, I have hex 40, 41, and 42, and that's wrong. It's 41, 42, and 43. I'm off by 1. But at any rate, the color table is only 32 bytes long, and it has a foreground background byte for each color, and that maps to, like I said before, 64 times 8 bytes of the pattern descriptor table. You can only, this is 8 characters worth. The other thing to note is that the pattern is linear in the pattern descriptor table. The 8 bytes that you need to describe a character. Yet when you display those characters, they are the top row here is 2 bytes, and here's the linear representation. The 78 is across here. The 24 is the next row. I'm sorry, yeah, that's right. 24, then 24, 38, 24, 24, 78, 0, 0. So it's 2 bytes per row. What's that?
1 byte per row. It's 2.
No, it's 2 bytes. Well, you're right. I'm sorry. Yeah, 2 nibbles, 1 byte. Exactly right. We'll come back to this in a minute. I'll get this back to the previous. Okay. All right. Now, to the plot. All right. I'm going to just mark this. I don't use this laptop keyboard that often, so bear with me here. That's not going to do it. Oh, I see. All right. Let's start up the emulator. Classic 99. And I'm going to paste that code that I'll go over in a little bit. How much time do I have? All right, as far as the axes go, I'm going to use a mode which makes it easy to see bitmap graphics, but you can issue commands that you can see. If I were to go to bitmap graphics right now, I could type in commands, but I wouldn't know what I was typing. But in this mode, I have 4 lines of text that I can issue commands. All right. What I want to do is to do. There's a function here called doPlot. Can you see that? Is that, can everybody see that? Okay. doPlot, and it has different other words that it executes. I'm going to execute those one at a time. All right, here's the x-axis and the y-axis. And then I'm going to go from -5 radians to +5 radians. That was the challenge. And run the sine plot. Now, once we got this done, we all thought we were done. But then he said, no, you got to label the axes. And they said, no, nobody said that. Well, it was implied, I suppose. But anyway. This is easy, this part, because the sine function is part of the floating point library, so it's easy enough, but you have to convert all of the numbers to floating point. It uses a radix 100, base 100 method of dealing with floating point, and that takes 8 bytes per number, whereas numbers on the stack in FB4 are normally just 16 bits wide, 1 cell wide. But you can't do the same kind of mathematics with integers. You have to be clever. You have to use tables that would be faster, because floating point, even though it's not using any GPL, it's still slower than integer math. Okay, with the characters, even though the bitmap graphics, you can deal with the per dot plotting, which is done already in FB4. It's I rewrote the TI 4th, high level 4th, which was very slow, into assembler, and so you don't have to worry about figuring out where on the screen and what character you're dealing with. One other thing I should say about bitmap graphics is the easiest way to deal with it is you have 768 character positions, just like you do in graphics mode, but instead of having only 256 bytes for 256 patterns to deal with, you have 3 times that, which is 768. The first third of the screen, you have 256 unique characters, but the clincher here is that you have 256 unique positions now because you can have one character per position that doesn't repeat anywhere in that 256 byte block, character block. And with the second third of the screen, you have another 256 characters, and the third you have another third, another 256. So what you do is, and you don't have to do this because it's done for you in most in the TI fourth and FB fourth, is that the screen image table starts at the top and it's 0 to FF hex or 255 decimal for each position, 0, 1, 2, 3, 4, and so forth, down to the last position, everyone with a different character code. And then you start over with the next 256, and you start over again in the last 256. So now the pattern descriptor table is it 8 times? Yeah, 8 times that, because you have to have 8 bytes per character to define it. So you have 6144 bytes in the pattern descriptor table, and you have the same number for the color table, so that you can define each set of 8 bits differently. To deal with characters, you can use the 8 by 8 that you see at the top here. The characters are actually using only 6 bits across because they're the space. You need the space that a column of, in fact, it's 2 columns of blank pixels will give you. That's why in text mode, your characters they're the same characters, but they're closer together than they are in graphics mode. So what you're seeing with these four rows up here is what the TI folks did for the. How many of you remember the 64 column editor in TI fourth? All of the characters are half a normal character wide. So you have, because you have 4 bits across, you need 1 column still for a space so that you don't have characters running into each other. So now you have a 3 by, what is it, 6, 7? A 3 by 7 grid that you can design a character in. Makes for some rather squirrely looking characters. But again, once again, you have this linear array of characters in the pattern descriptor memory table, and so you have to set the characters. Now you have one column of bytes. I'm sorry, nibbles. Back to this screen that showed the. The left side is all you have for a character from here to here. Well, you have a space for 2 characters, but it's 4 bits by 8, and then this half 4 bits by 8. So in order to set a line of characters, you have to every other character has to be shifted by 4 bits. So the first time you're writing to the leftmost side, and the second time you have to shift it right to the right side, and it gets to be a little difficult to think about. But they did it with the 64 column editor, and the table. I gotta find it here. Is in the back, one of the appendices of the TI fourth manual and the FB fourth manual. Where am I? Oh, here it is. It's appendix H, I think, yeah. Anyway, you can see these definitions, hopefully. Can you see that clearly? You can see they're only 2 bytes wide. Rather than 4, I'm sorry, 4 bytes wide instead of 8. And you have these 4, 1, 2, 0, 0. The first one is trying to think what character. That's blank. Blank, yeah. So it must be character 32. What I did I didn't do that. I didn't use the same technique that was used in the 64 column editor. What I did was to make up two tables just for numbers and space and the plus and minus sign. Now the plus minus sign and the numbers are all together. You can see here minus is just ahead of dot and and slash. Then it starts 0, 1, 2, 3 up to 9. So what I did, the comma is 2 or 3 before. So rather than wasting a lot of space to get the true space character, which is number 32 or hex 20, when the 0 starts at hex 30, was to just define the comma, since I didn't need it as a space. Just it was all zeros. So that's what I did, and then I interspersed the 4 bytes with 4 bytes worth of zeros. So let's say this character here that's defined with 0, 4, C4, 4, 4, I would put it in as 0, 0, 4, 0, C0, 4, 0. Just put a 0 every other character. And I did that with 2 tables where I offset one to the left and the other one to the right, so that I can decide whether I'm on the odd number or the odd position or the even position, and just or the graphics with the right part of the character position, which is, I'm still dealing with an 8x8 position in the bitmap graphics. All right. Going back to the program, here's the defining an x step constant, which is, I'm starting out with 0. 4 zeros, that would define a floating point 0. And then a y max of 70 pixels, which would give me 140. Now the thing to remember here on the screen is that I cannot afford to plot anything in the top four rows, character rows. Otherwise, these characters are going to change. I don't want that to happen. So I'm limited to dot row 32 down to the usual 191. And of course, I have a full 0 to 255 from left to right of dots, pixels across. I don't want to bore you too much with all this. I wanted to get that. Here are the tiny character patterns that I was telling you about. I defined plus, comma, as using it as a space, minus decimal point, slash is just there, I don't use it, then 0 through 9. And then I put the character patterns in the right half in the next one. And so that I can then OR those patterns with what I pick up off of the screen. I have to pick a segment of the screen, and I decided to use 6 characters to do the axis labeling. So I figured we could do plus 1.0, that's 4 characters, maybe allow for another couple if I needed it. And I was always going to pick a position on the screen where I would left justify. So I decided to use only 3 character positions, which gives me 6 half characters. All right. I pick up the segment of the screen based on the column, the dot column and the dot row, which is where I have get seg. And then put seg will put it back once I have manipulated it by ORing the half characters that I want. And then I wrote a label word here that gets the segment and does the number of characters that I put in the string from 0 to that count, and then decides whether it's odd or even to get the odd or the left justified or the right justified table that I showed you above. And then here's how I use it. Here's this X labels. You can do the 0 to 14 is dot column 0, and at and at 14, let's see. And then I put a string in here and then call label to put it in that position. So here's X labels. And Y labels. That was that. Decided to try to do some other plots along with this. So I'll change the color. Somebody give me a color, one of the 0 to F colors. I don't know if anybody knows those off the top of their heads. I know 4 is dark blue. Okay, let's do red. Let's put it in hex mode. What's that?
Might be 7.
I know 8 is red, I think 7 is cyan.
7 is cyan. Well, let's do 7.
5 is assembly or basic.
Okay, so 0 is transparent. That's what we want the background to be. 070 decolor store should change the next plot to that color. And I have a function called, interestingly enough, cosine plot. Oh, it's not working. Do you know why?
It's a GI demo?
That could be. I forgot to put the range on the stack, so it screwed up. I'll see if I haven't messed up the system totally, we'll see if I can get away with putting it on here, or if I have to reload the whole thing.
Change the color.
What's that?
Change the color. 8 is dark red.
Oh, okay.
At least in assembly.
Oh, that didn't work. There it works. Can you see it? Notice that it's changing the colors that of pixels it's crossing. More than just that, it's because it's got that 8-bit granularity. And then -5 to 5 tan plot. Oh, I don't want to do that. I want to change the color. So what do you say? It's 0, 8. 0 will be red. All right, let's do a tan plot.
You want to find the range first?
Yes, thank you. I'm surprised that I haven't destroyed the system already by doing that before. Now, I used a multiplier. I divided the tangent by 10 so I could get it on this 1 to -1 ordinate, because the tangent has an asymptote every, what is it, every 180 degrees. It goes to infinity. So you wouldn't see much of a plot down around the x-axis. Okay. Rather than bore you with other details I wanted to include, which was to explain a little bit better what this program is doing. I will forego that and take any questions you might have.
Lee, you've got all the time you need, so don't
Yeah, well, again, I don't want to.
don't worry about that. I mean,
Okay.
people come from all around the world to learn about this stuff, so don't shortchange them.
Okay. Well, are there any questions at this point that you want to clarify? Klaus?
I would have one regarding, you said you're independent from GPL
Yes.
and XMR routines.
Yes.
Would that allow them to run FP4 also on a 998? You think so?
I don't know. FP4 does make certain assumptions about the architecture of the 99.4a, and it isn't that FP4 does not ever use GPL. It rarely uses it. The floating point library doesn't use it at all because it's essentially a duplicate of what was in GPL and XML called routines that are in the console, ROM and GROMs. Those have all been hoisted into bank 3 of the cartridge and are using whatever space it needs in RAM, but the actual functions are in ROM. The file I/O in FP4 does use GPL. It uses the MG, the milligraphics, GPL link, and DSR link, and those it allows. You could use cassette. I've never done it with FP4, but you presumably could load a file or save a file to from cassette, but it's using the GPL link. So it wouldn't be safe in that regard. As to whether it could be written to do that, I suppose you'd have to use a non-GPL routine. I believe I did include the GPL LNK function if a person wants to use it, but you don't have to. There are some. There might be some GPL functions that might be useful that are not part of the floating point math, the transcendental functions that you would want to use the GPL anyway for. So I don't know, but that's a long way around to answer your question that it's not a safe assumption.
Thanks.
Hal?
Jim Wild on the chat function asks, what's the best way to get started in FP4 and where does he get the cartridge?
Okay, the cartridge is available for me if you want the physical cartridge. You can get boards from yeah, right? You get boards from Jim Fetzner. If you want to burn your own EEPROM, the files are available on the main FB4 thread on Atari Age, as well as my website, which is fb4th.stewkit.com. StewKit is STEWKITT.com. The latest that's up in both of those places right now is Build 11, which has the 2 bugs that I mentioned. Build 12 I'll have up this week probably, but certainly by next week, mostly after I get home. The FBlocks file that I modified to go with this is only cosmetic changes. The only thing that won't work once you get FB4th Build 12 is the binary loads. I think there are, let's get back to text mode. Okay, this thing is stopped. I'll have to start it over. I did mess up something. Okay, the menu has, the 64 column editor has a binary. The TMS 9900 assembler has a binary that you can load. The stack-based string library does, and so does the TI 4th block utilities. So those 4 will not run on anything but 12 or later. Well, actually 12, because there's a test on each of those that makes sure that you're running 12. So just in case there was a kernel change, it'll still work. It's slow. The 64 column editor may be the longest of these. If you load it by doing a 6 load, this right here, if you just type 6 space load, it will take you quite a while, because there are at least, I think, 9 blocks to load, and each of those blocks is being interpreted by the text interpreter. So it does take a while. That's why it's so nice to have the binaries. You can load it in practically an instant. So I don't know, I guess, does that answer the question?
I don't know.
Anybody else? Well, back to the program. Are there any questions about how I did this with the tiny patterns? I guess I run. Yes. What?
Yes, it does. Thank you.
I'm sorry. What?
You said, yes, it does. Jim Wow said, yes, they answered.
Oh, okay.
So if you were to define all those characters like that, say in an extended basic program, and try to type it there, you would have a tiny little letter with a space next to it, and then another tiny little letter and a space next to it. So it would look very awkward.
Well, yeah. If you're defining a character, if you're trying to use the character patterns available in extended basic or basic, and you redefine them, now you have a pair of characters for each of the, whichever ones you define.
One on the right side is just
Right. Yeah, that would be awkward. I'm not even sure how you would manage it that way. What we're doing with these half characters is actually using another table and grabbing code from that, pattern code, to OR with another character pattern, the one that would have 8 bytes instead of 4 bytes. And the way that the authors of the TI 4th 64 column editor, which is the same one that I use, that's in the utilities of F blocks, I modified it a little bit because there were actually some mistakes in the other one. The way they did it was different from what I did here. I had the luxury, because I'm only using a very small subset of the pattern table, only about 14 or 15 characters, and I doubled that. Well, if I were to do that with the regular pattern table, I'm now using a couple K of memory to just mess around with that. So it was useful for the TI 99.4A or TI 4th 64 column characters to do the shifting to get the ORing, because you had to shift 4 bits one way or the other to OR with the right position, and they had a routine that they called smash, which would set the 64 character line before it displayed it on the screen. Okay. This TNL, the constant TNL and constant TNR, stands for, oops, didn't mean to do that, stands for tiny number right and tiny number left. And you can see that I am defining it by starting with the beginning of tnums, which is that table up here, and subtracting a number from it. Here's tnums 0156 hex minus, and then for TNL, and tnums 00DE minus for the TNR constant. What that is doing is referencing the beginning of TNL and TNR to character 0, ASCII 0. Even though we'll never actually use it, because it actually winds up somewhere in Gram space, I think, because it's a hex 9000 number, and we'd never want to reference that. But it gets me to, if I have ASCII 7 and I add 8 times that number, I'll get into one of these two tables to get that pattern for that character. Okay, well, okay, I think that's probably good enough. The sine plot, cosine plot, and tan plot functions are fairly straightforward. We're just calculating the function going from -5 to +5 and then modifying it to plot every pixel over that range using the 0 to, well, actually I used 2 to 250 rather than 0 to 255, so I'd be in a little ways. Made it more convenient too to have a 250 rather than another odd number. And then to plot the code. Here to give you, let's do one thing and then I'll quit. Let's go back to split 2 mode, and we can play. Remember, it starts at column row 30, dot row 32. So if I were to say plot at column 30, dot column 30, and dot row 32, you see the dot directly below the blue? Right there. Why do I have two mice? Huh. Oh well. What's that? Okay. And then there's also a line function, which Tercy might remember. We did this thing quite some time ago now, a few years, where we were using the Bresenham algorithm to get a quicker line draw, and that's this function is using that. Let's draw a line from dot column 0 and dot row 32, which is right here, and let's draw it down to the bottom right, which would be dot column 255 and dot row 191. So that's pretty quick. If you were to do that in TI-4 that defined that function in 4th high-level code, we'd be watching that dot, 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 dot. Any more questions, and I'm done.
Well, the fellow that asked the question said he's looking at it right now, checking out your website, I guess, and checking it out there. So he thanks you for the instant help.
No problem. Anybody else? Anybody that's still awake? Okay, that's all I have.
Lee, thank you very much. I've learned a lot. Don't know how. Remember, I've tried to use Forth with success so far.
Well, Vic, I believe you had a presentation you were talking about?
I had some stuff, but nothing would work.
Well, yeah, there you go, perfect demo. You're gonna give it a shot?
For one presentation today.
The FB4 running Dark Star, but I need a new version of FB4 to be able to run it, because I have only the old version of FB4. However, I do have some stuff that shows the evolution of a couple gorilla gods.
Can you bring it up here?
Yeah, I guess I could.
Okay, you want time to set up, or is it portable? And on a disc? Okay. So, our next presenter will be Vic Stirp, the president of the ChicagoTIUG Group. Now, once again, I'm going to remind everybody where the banquet is going to be. It's going to be right down the street at Panera, on this street, right out here, out this window, and straight on down, it's the second block. We will try and get there sometime around 4:30, and sort of you take your food back to the back room. There's a back room there that's kind of glass enclosed. I think everybody's been there. Is there anybody that hasn't been there before? If you haven't been there before, follow someone who has. And you order your food. They call your number or call your name. You pick your food up, you go in the back and infiltrate that room. We will take it over by bits and pieces. There sometimes will be somebody back there on a computer trying to do their homework or whatever. We will drive them out eventually, and we'll have the whole room. And we will then, after dinner, have the presentation of the John Birdwell Award, and we will also start drawing for the door prizes. We have quite a few door prizes to give away today. So for all those who are at home and haven't been able to come here, too bad for you, you don't get a door prize. I've been trying to figure out how to include all the people who are watching this in the door prize drawing over the years, and I simply don't know how to do it. I have a hard time sending a P-box full of stuff overseas. If someone can come up with a jet plane or something like that that they would like to loan me, I'd be more than happy to send stuff to them. Vic has an offer for any of the software in the Chicago I'd really like to see someone take him up on it. Hopefully that some of that money would even go to the ChicagoTIUG Group. Now, one last thing for everybody here. If you haven't signed up yet, please do so. I think everybody has signed up, but if you haven't, please sign up, and then you'll be eligible for the door prize drawing. We've got some interesting things. We've got some little gadgets. We've got some, I think we have some flash drives as well. There are some things back there for sale. There's some discs that contain all of the software that's been given away at the fairs for the last few years. Vic has made DVDs of those flash drives he's given away and the CDs that he's given away. And there are also some freebies back there. Please help yourself to a bottle of water. Eat the candy. Anything you don't eat, I probably will in the next few days, and I don't need the candy. I really don't. So please help yourselves. There are floppy disks back there, 3.5-inch floppy disks. There's a couple of cases back there for floppy disks. Help yourself to those. Take them home. Do whatever you want with them. Just don't make me carry them out to the car, please. What else have we got? Okay, John, are we set to go? Okay, Vic, are you ready?
Just about. It's just I have to load all the software from the different sources so I can demonstrate.
Okay, well, I'm going to mic you up and turn this over to you. There's also, I think, before I do that, where's Jim? Jim, is there some other stuff that's being given away on the middle table there? Is that?
There's still a couple of bags of cables, some TI literature, a couple of cartridges on the middle table.
Okay, there's some free cartridges, some bags of cables, Jim says, and there looks like a couple of boxed up cartridges in the original.
Console power supply, if anyone needs one.
and some power supplies. If anybody needs those, please take those. Do we have any other announcements that anyone would like to make? If not, don't forget, you got to get your car out before 6 o'clock, okay? All right. I mic you up.
All right.
Let's see, where's a good place? All right. Without my glasses, I can't see a damn thing here.
You want mine?
No, I just pray for me. There we go.
Okay. All right, howdy. Victor Stirrup, I'm president and librarian of the Chicago User Group. I'm not a high roller, but over the past few years, I've managed to get a Final Grom 99 for running a variety of different cartridges rather than having to have a suitcase full of cartridges. And I've got a Nano PEB for running virtual floppy disks instead of having, again, suitcases full of floppy disks and carrying a P-box around. So this time around, we're going to run Grail of the Gods, which, well, need help. How do you pronounce?
Ciro Barilli.
Ciro Barilli, who's the head of the Italian 994A Facebook page and users group. He's announced last year a game called Grail of the Gods. And this was the prototype, so we'll show that first. And I have to currently load from the compact flash card the finished games. So bear with me just a minute here. And in disk 1, we're going to load volume 1092. And then we'll mount in volume 2, or in disk drive 2, volume 1097. That's where they're stashed. So pressing enter, we come up with the title screen for the Final Grom 99. Pressing number 2 comes up with its built-in menuing system, which shows, let me redo that and reset it. Might as well step through this from the beginning. Reset the Final Grom, press number 2, and it shows the menuing system for the Final Grom. And this is how I got it from Gregory McGill, but I've added on a few things. So letter A is TI demos, letter B is demos in F18 mode, C is devices, D is education, E is games listed from A to M, F is games listed N to Z, G is homebrew cartridges, H is MBX cartridges, and then as I get cartridges online, I've been putting them in I and J. K is tools and utilities. You got Cortex Basic. You got a whole listing of games under M, Parsec, and the PR editor. But we're going to go with games A to M, so I'm going to press letter E. You get a loading wheel in the lower right corner. And if you look at the upper right, top right of the screen, you've got a lower parenthesis. You've got a comma on the left, 1/7, a period, and a right parenthesis. If I press the period, if you watch that, it goes to page 2 of that menu. Press the comma, it goes to page 1. So there's actually 7 pages on this A to M listing of all the games that are listed. What we're interested in today is letter R, Grail of the Gods. I think that was like 1.0. It's loading. There you go. Grail of the Gods by what? Eyeball, TI version by Majestics, loading level 1. Press any key to continue. Okay, so this is in ASCII characters. Your on-screen character you play is the @ symbol. I'll press the D key and we move them to the right. I hit the snake. So it's an adventure game, and I'll go for, got 1 bite, 1 damage. You see your score on the right. And I'll press the X key to go down. Oh, I'm still battling the snake. I'm not allowed to move until I finish fighting him. So I took 6 damage, and our health has dropped down to 39. The snake bites, got 1 damage. I hit the snake, got 3 damage. The snake bites for 2 damage. I hit the snake for 3. I finally killed the snake, but I lost like 5 points on my health. Now I can move to the right, and this draws the dungeon as you move. Again, I'm close to a rat, so of course I have to fight him. I'm not allowed to move. And you have to fight him just by pressing any motion key till you finally kill the rat, or it kills you. So you can move around through this maze, and that's a dead end there. I can't move down any further, but there's something there to the right. Okay, so it's a nice implementation of an old DOS game. So we'll quit this and press the red reset button on the final GROM to reset the menu. And we'll go back to the final GROM, and we'll go to C for device, and page down 1 page. I prefer RXB to run stuff just because it's got a disk cataloger in it. And press enter. And this should be running in the EA version. There we go, Grail of the Gods. Graphics enhancements. Okay, so now we can run in classic mode or enhanced mode. We'll go to classic mode first. My choice number 1, press enter. Level 1, press any key to start. Okay, so here, this shows how it was the original graphics. And you get to fight the monsters. I'm going to quit this for now. Reload it. Do a directory of disk 1. Load the dungeon, press enter. RXB picks it up. Okay, now we're back at our title screen for Grail of the Gods again. Now we'll go for enhanced graphics. And this comes up real nice. There. So now we got bricks. We got a little guy, and it draws the maze. Oh, there's some gold there in the lower right corner there, but how to get to it. And this is real nice because you don't know what this dungeon looks like until you actually start playing it. I'll move to the left, and I found 6 gold. Okay. So yeah, some of these games you see the whole maze at the once. And let's see what that red dot is. I bet it's a... Oh, I was hurt by a trap. Okay. Lost about 5 health points there. And let's see what this thing is on the right. It looks like a ghost. Now we have 39 health points at this time. I hit the goblin, damaged him by 6. Doesn't say what the health points of the monsters are. Again, press fire any key to start. And the goblin pokes you for 1 damage. Now we're down to 38 health points. Hit the goblin, damaged him by 7. And again, the goblin pokes back. Not much of a monster. No, he's getting better at it. Got 2 damage. Hit the goblin for 3 damage. Goblin pokes me for 1. Boy, he's not very, doesn't hit very hard, but he seems pretty durable. Takes a lot of damage there. I'm down to 24 health points. I don't know if I'm going to finish this. Oh, now the goblin hit me for 7 damage. You know what I think I should have done first? Was, I finally killed the goblin. Is gotten a weapon first rather than fighting these creatures with my bare hands. But anyway, that's from the Italian. There's the sword. A magic claymore. I'd pay $1 for that. And now it's a rat. Hit him once, hit him 3. It's a fun little game based on, they described it as a rogue-like game. So, any questions on this? It's at the Italian 99ers Facebook page, or where I found this. And last year is what that prototype version was at. Reset the final ground. Go back to the final ground menu. This is interesting, down on M for games. Let me see which one that is. This is one listing on the final GROM, but it has its own internal structure and games here. Ant Colony, Barrage, Black Hole, Boxer. These sound a lot like the John Phillips type games. You press the space bar to get the second menu. Munchman 2, Pinball, Rotor Raiders, Stargazer 1, 2, and 3. That was a nice one that we demoed at a regular TI meeting a few months ago. Tetris or Tris. And it's our old game Tetris, where you can move the piece left and right. You can rotate it 90 degrees at a time. And the enter key drops it. So yeah, the Final GROM, I can heartily recommend it. It comes with more games than you can shake a stick at. And it's got your utilities. Enough with the games. Let's try some of the utilities on Final GROM. Hang on. Have to reset the cartridge. On the Nano PB, I got the compact flash card with the ChicagoTIUG user group library installed on it, and the Tiger Cub library. Dr. Eric Bray had announced some years ago that there was a torrent download of much TI software, and the Tiger Cub library was included in that, but it was incomplete. It was missing like the last 10 or 20 discs in the set. And I got on the Western Horizon site, and they had those discs, but I found out that my collection that I had downloaded online had 6 discs that weren't in the Western Horizon archives of Tiger Cub. So I'm going to have to find out which 6 those were and upload them so everybody else can have access to those.
Hey Vic,
Yes.
if I remember right, at least one of the discs that was missing from the WHT set was because when they read that disc, the disc didn't read right, so it
Was corrupted?
corrupt.
Okay.
And people have been trying to find that specific disc.
Yeah, I'll have to see what those missing discs were and see if they actually run off the set that I got. I had bought a bunch of discs from Jim Peterson when he was running Tiger Cub. I might actually have the physical floppies. For F-18 funnies, we're going to press number A, demo for the TI, and they have a whole bunch of different demonstrations here. I'm trying to find one that's real nice. We'll just start at the top with B, animation. And this is working in TI mode as far as the graphics. And I think I recognize this. This was from Commodore, of driving down the street, like Bill and Ted's Excellent Adventure, all the palm trees going by. Reset the machine. Yeah, the only thing is you always have to reset it to get back to your regular menu. Okay, so we had C, a bitmap demo. And this again shows the colors and the graphics that are available on the F-18. Anything in particular somebody would like to see from either the Nano PB on the disk files from Tiger Cub or the Chicago library? Let me reset it.
Go through the compact flash. Hang on. I have to reset the final GROM correctly. There's 2 reset buttons on it. One resets the console, one resets the whole cartridge. We'll go to device and page down 1. We'll go to RXB. And I have stashed my compact flash manager on virtual disk drive 3, because few TI programs ever look for a 3rd disk drive. So I can just leave it on the Nano in that position. So we can go to volume utilities and we can do a list. So if I press number 6, list, here's the Chicago library, disk number 1 it goes to a couple hundred. You could list down here. And they just happen to be numbered the way I did this disk. They're numbered the same as the actual volume. Now the volume is what the compact flash refers to. So if you want to load a virtual disk in disk 1, you would tell it to call mount parenthesis, and then what disk you want, disk 1, disk 2, or disk 3, and then you would number in the particular volume number. So say like we want to look at volume number 111 of the Chicago library. I'll reset the console here. And in BASIC, do a call unmount 1, and that removes the virtual disk, and then you call mount. Okay, so reset, we'll go back into RXB, the EA menu, D for directory, disk 1, and there's the Chicago name up there, Chicago, 0111, cookbooks, Christmas, data file, database, load Xmas. We'll just, if we do a reset, just tell it to load disk 1 load. User group, Chicago TI user group presents loading DBase 99. Please be patient. Also, it's loading a database. I have no idea what's on that disk. I was just grabbing something at random as an example to demonstrate how this works.
I think it's got social security numbers and passwords.
Okay. Well, that stuff's been hacked for... It says it's loading the database, but I don't know if there's actually a database there for... There you go. Enter today's month and date. Oh, this ought to be fun. No, it's not 10. What am I thinking of? Working in last month. Let's see how it handles that. Yeah, let's say the database is defined. Insert data disk and drive number 1. Press enter. Well, let's see if they put the data there. Should be interesting to see what's... Okay, database 99. Data name computer books contains 31 records. Last used on 4/19 of 88. Okay, let's view the records. Enter record number or abort. How about record 1? Title, Fourth Fundamentals, Volume 1. Author, C. Kevin McCabe. Publisher, Dilithium Press. Price, $15.95. Comments, language, fourth. Okay, next record to view is number 2. P to print, 0 to exit. I'll press number 2.
That's a different price for that one.
Yeah. Okay, record number 3, a bumped up one. Managing business with multi-plan. Okay. So, nice little database program. There was other stuff I saw on this disk too. I'm going to reset the computer now. Go back to RXB. Go back to the
EA. We'll do a D directory on DSK1. And I saw there's not only a load program here, but if you step down, there's load Christmas. It's a little early for Christmas. It's not Thanksgiving yet. But if I press the space bar in RXB, it'll load XB files. If I press enter, it'll load EA files. So that's why I like RXB, because it saves a little cartridge swapping. Again, I haven't run this before in my life, so I don't know what's going on. Christmas scene. Combined letters in names must not exceed. Your first name, please. The spouse. I'll just put her name's Jean. Last name. Okay. Background color.
Red.
Dark red, medium red, or light red?
Light.
Okay, so that's 10. So this is real nice. I got something that weighs about 10 pounds, and it replaces, like I said, a suitcase full of cartridges and a couple suitcases of floppy disks. I remember what our previous librarians went through in lugging around the boxes that had all the floppy disks of just the Chicago library. And here I've got the Lyman Library, Boston Computer Society, Tiger Cub, everything else.
Is there sound, Rick?
Well, let's see it. It says press I for heard the bells, S for silent night, or B for both. Press I. I don't have a sound cable hooked up on this.
Oh, well.
John, we gotta have the sound output on the TI. You got one of those sound cables?
Sound, just normal?
For RCA.
No, I don't have
Oh,
anything
okay.
easy right now.
Okay. Well, unlike the CAT Electronics replacement for the TI, mine doesn't have a built-in speaker. So if it's playing sound, we can't hear it. So another thing you can do is, at least from RXB, pressing 3 for loading off of disk 3 and getting the CF Manager. We can look at volume utilities. Catalog is number 1. So let's say I want to catalog a disk like 111, and there's a disk catalog. This is from the Compact Flash Manager software. I can go back, catalog disk 112. So it makes cataloging stuff real easy. You can rename disks, format them, list them. The list is the only thing that takes a little while on a 1 gig compact flash card. Yeah, it's old. I had to buy it on eBay. It holds 1,250 volumes of virtual floppy disks. So to get up to 1,250, I have to Control X and page down. I just can't type in a number and start at that particular number and catalog them. So what I have had to do is take a loose leaf binder with school children's lined notebook paper and just write down all these numbers and write down what all these disks are. Because, okay, we've moved down. This is, I'll see if I can explain what this is here. When I first got the compact flash, it came up loaded with the 32 meg compact flash card of software. So here on this, where I've got it stored, 235 is volume 1. Well, on the original compact flash card, that's these compact flash utilities. They wanted to make sure you could always get at them. And I stashed it up here after the Chicago Library, which ended at 234. So 235 is volume 1, and there's about 35 discs of software that came with the compact flash adapter. Some of these were Altman discs. Some of these were database discs. Bill Haskell had 272, the game-based disc, for all the game cartridges he had for the TI database programs. And volume 31, 32, 33, 34, those are blanks. There's no software stored there. If you look at the right-hand column here, how much free space you have and how much is used. And then we got back down here, Mirage software. There's just a ton of stuff here, probably about 3 lifetimes worth. And then we got into Rasmus Musgard. Here's a 306. Here's his titanium game. So I stashed it on there. So this gets a little haphazard because I just started stuffing things on here as I got it. So I had to have a written list. This looks like the Vioto-360 is some sort of shorthand that John Phillips used from the Asgard software library. And so I had downloaded the whole Asgard software library when that was available. Unfortunately, a lot of these disks don't seem to work. I don't know quite what the problem is, but there's so much on here at this point that if a disk doesn't work, it's not that important. All right, now we get here down to blank disks. These are initialized disks, 1598 sectors available, only 2 have been used. Now we get down to Tunnels of Doom, Remind Me.
Rick, are you looking for something, or?
No, I'm just showing what's on this compact flash. And to get down to like 1200, here we're in Tiger Cub. These are all the Tiger Cub discs. So is there a particular one you wanted to look at?
No, I just wondered where you were going with this.
Mm-hmm. It was just to demonstrate that it takes a while out of 1,250 virtual floppies on this card. For me to manually look down through it takes a long time. And it might seem tedious to actually write this down or type it up on another machine, but it's something I only had to do once. Once I did it, I could just flip through the pages and I could see all this stuff. There, disc 120. Oh yeah, that was always good. Robot Jokes, do you remember that one? It uses a T. Anything else on indexing them or finding a particular file?
Any questions for Rick about the final drop or the Chicago Library or anything that we do?
I usually follow the chatter online from either the Italian user group or TI-99ers or Atari Age on what's hot and what people are talking about. And if they have links to a .dsk file or a bin file, I can usually download that and put it on the machine. And then for the next month, that'll be the demo we do. You know, that decides what discs we do. Remember last year we did the a few years ago, we did John Phillips cartridges demonstrations of all his stuff, and then we did the Red Baron. That was a big one. Owen, back there? Oh, Owen Brand enjoyed playing the Red Baron. I had a whole book printed out. In the Chicago User Group newsletter, there were articles on Red Baron. I think there were 10 or 11 of them.
Yeah, Dave Hall.
Yeah, and there were suggestions on different things, because Red Baron is all seat of your pants flying. There's no GPS, there's no eye of God looking down at you while you're flying. So you take off, you know what direction the wind's coming from, and what direction you're headed, and you actually got to count on your watch how many minutes you go to get to certain areas. It's a lot of fun. But I digress. That's it for my demonstration today.
Okay, thank you.
Welcome. There you go.
Thank you. Well, that concludes our presentations for this particular fair. We're already making plans for next year's fair. Now, as you probably already have been told about 1,000 times if you've been here regularly, we have to work around the Northwestern football, the home schedule, because anytime there's a Northwestern football game, you can't get a hotel room in Evanston or even the surrounding areas. We don't have anywhere to the east to go because that's the lake. And by the way, if you haven't been down to look at the lake lately, it's up quite a bit. Whenever the wind blows out of the east, we get 8 and 9 foot waves down there. But anyway, we will be meeting. Right now, the tentative schedule that Northwestern has given me shows that the 7th of November will be available. However, the schedule is tentative right now because that's a bye week for them, so they may switch it around, they've told me. And we'll let everyone know at a later date when that schedule is firmed up exactly when the fair is going to be. If we weren't to have it then, we would have to have it in December or in the middle of September, because the way the schedule works, we don't want to obviously have it during Thanksgiving, and we don't also want to get too close to the ChicagoTIUG in Europe. So the 7th of December right now would probably be a pretty good date for us. However, well, let's hope for a little bit better weather. The weather this year was really awful. Well, thank you everyone for coming. I want to remind you about the banquet, the infamous pub crawl, and especially about getting your cars out of the garage down below. We had one year when somebody got stuck overnight in Evanston because they couldn't get the car out. And thanks again for coming. Thanks again for watching, if you're watching at home. We appreciate all the comments. This year, our video and our audio seems to have improved quite a bit. People have been commenting about the fact that they like it a lot better. So I want to thank John, who's our chief engineer, Jim, who helped out, everybody that helped out. Waleed brought his projector, which is much better than the projector that I bought, and thank you for that. Thanks everybody who drove a long distance to get here, and the evening has just begun, so hopefully we will all have some fun at the banquet. There is as I mentioned before, John, can you hand me the book from the Geneve? We have a Geneve that we're giving away tonight. Here's the manual. It comes with its own P box and its own monitor, so it's a worthwhile thing to stick around for. Hopefully we'll all get over to the Panera about 4:30. That gives everybody a chance to get back to their hotel, to park their car in a different place, whatever. Is there anyone here who doesn't know where the banquet is being held? If you don't, it's 1 block this way, down this street here, at Panera in the back room. Okay? I think everybody probably has been there before, knows where to go, knows what to do. And once again, thanks everybody for coming.